and then I will tell you that how to apply the regression in Microsoft Excel. So initially, if anyone of you don't know what is regression is, you can see on the image on the right side of your screen, there is a straight line which is drawn as a chart, and there are few dots, and this line is always drawn on the closest or the minimum distance of those dots. So the regression itself called like regression takes as a group of random variables through to be predicting y and tries to find a mathematical relationship between them. So this relationship is typically in a form of a straight line, as you can see in the picture, which is called the linear regression. And remember that we have non-linear regression is also there, exist. But now in this webinar, we will be mainly focused about the linear regression. So more about linear regression is that linear regression is a statistical tool in Excel that is used as a predictive analysis model to check the relationship between two sets of data of variables. And using this analysis, we can estimate the relationship between two or more variables, and we can see two kinds of variables. The first one is dependent variable and the other is independent variable. And sometimes in few examples, we have only one independent variable, and if we move forward for more practical approach, sometimes we have more than one independent variables like 2, 3, or 4, even more than that. Okay. So furthermore, proceeding towards the next slide. So linear regression, we have two variables, two different types of variables, dependent variable and independent variable. The dependent variable is the factor we are trying to estimate. The independent variable is the thing that influences the dependent variable. And we will look into the different examples in next few minutes in Microsoft Excel that how we can perform the regression. So there are two pictures on your screen. The one is called the linear regression and the second one is the nonlinear relationship. So about nonlinear regression, nonlinear regression is the model which is used widely in the statistics field, where the dependent variables are modeled as nonlinear functions of model variables and one or more independent variables. But our mainly focus of today's webinar will be how to apply the linear regression. Okay. When I will be applying the regression in Microsoft Excel, you will be come up with a screen, which is picture is shown on the right side on your screen. We will be input Y range, we will input X range. We will check on certain options which are fundamental to apply the regression. And definitely there are other options such as residuals, residual plots, standardized residuals, normal probability plots. So all these definitions have been written on the left side. And if you want to read it out, or if you want to have more understanding towards the statistics, you can go through different articles or blogs on the websites on Google. But as I told you that this webinar is more towards the practical approach that how to apply the regression in Microsoft Excel. So let's get start with the demonstration part in Microsoft Excel, and then we will understand that how to apply the regression. All right. So I have the Excel workbook interface here, and I hope that all of you can see my screen. Um, Kindly let me know if my screen is visible to you, Excel screen is visible to you, right? Okay. So I want few more participants feedback that are you able to see my screen, Excel screen? I'm waiting for the participants to give me a feedback so that I can cross check on my side that you are able to see the Excel screen, and then I can proceed to the linear regression part. Okay, so now as my Excel screen is now visible, and so let's proceed to the example number 1 of linear regression. As now you can see that the first example has two columns. The first one is the salesperson and the second column is the sales. Now the sales is considered as variable y, which is the dependent variable, and the salesperson will be considered as x, and it's an independent variable. Okay, so as I told you earlier in this webinar presentation that we have one dependent and one independent variable. Okay, and we will be going to starting towards a very basic example. Now as you can observe in the data, when we have no salesperson, we have no sales, and that's understood that we have no salesperson, there is no sales for the company. When we add one salesperson, the sales increase by 10. When we add one more salesperson, now we have two salesperson in the organization, so our sales increase with a variance of 10. Whenever we add one more salesperson, the sales is increasing by 10, right? So for example, if I add after 10 salesperson, our sales is 100, and when I add one more salesperson to it, for example, if I add one more salesperson, now we have 11 salesperson, so the next answer will be 110. When I add one more salesperson, the next answer will be 120, the sales number, because now our mind can calculate this prediction very easily that what will be the next number, because there is a standard pattern, a same pattern, a constant pattern is going on. Whenever we add one more salesperson, sales and increase by a 10. Okay, so now how we can do this kind of technique in by regression. Okay, how we can create a straight line to it. So giving you an idea that first we will select this entire data, which is based on two columns, salesperson and sales, and I will go to insert tab, and where I will click on this scatter chart button, and I will just click on this scatter chart, and quickly a scatter chart will be drawn, and you can see that all these dots is creating a straight line, but we have no line to it. We will add a trend line to it so that we can have an idea that how linear regression giving us the results. So on the right side of this chart, you will see three buttons: the plus sign, okay, the paintbrush, and the filter icon. So I will just click on this plus sign to add more chart elements, and on the last on this contextual menu we have a last option that is called trend line, and here we have a small arrow. I will click on it and I will go to more options. So on the right side, format trend line will open, and from here we will apply the linear trend line. Now it's also depend on the industry and their business nature that what kind of trend line they want to apply. Either they want to apply linear, either they want to apply polynomial or the moving average. So in most of the cases, and in this specific example, we are trying to apply the linear. And I will also check mark on two options. The first option, which is called display equation on chart, and the next option is display R squared value on the chart. Okay, and I will explain you that what these two equations means. It's very easy to read it. First, we will read R square is equals to 1. R square, for the simplified purpose, understand that R square is giving you an accuracy of the equation, that how much equation is correct. So R square is giving you the accuracy. Now here R square is equals to 1. So the ones means 100%. This means that y is equals to 10x is an equation. When we put any number to it, the equation will give us an output which will be 100% correct, because R square is equals to 1. So y here is the dependent variable, which is sales. X is the independent variable, which is the salesperson, and 10 is because every time we add one salesperson, the increment of 10 also add to the sales, right? And it gives 100% correct result. So our all the dots and the straight line is has no distance. So this is one of the type of linear regression, one of the example. The next example, and I would like to have the participants to give me a feedback on it in the chat window. Now in the second example, we have again two columns. The first one is salesperson and the next is sales. When there is no salesperson, there is no sales. When there is one salesperson, sales of 25 units, for example. When there are two salesperson, there are sales of 28 units. Whenever the salespersons are increasing, the sales are also increasing. But what happens at the last? When there are 10 salesperson, the salesperson has been increased, but the sales has been decreased. And one more factor you will observe that although the sales are increasing, but not with the same constant difference. Now the sales are increasing, but the difference is different. And also at some point, we have increased the salesperson, but our sales has been declined. So for example, if I add another salesperson, for example, 11 salesperson, what will be the next sales? So any one of you can predict what will be the next sales. I would like to have your comment in the chat window. After seeing this kind of a data where we have increasing in sales and decreasing in sales by adding a number of salesperson, if I add one more salesperson, so what will be my next sales? So any one of you can guess. Kindly write your response in the chat window. All right, so let's predict the next number. Okay, and let's do the linear regression. Now, for example, if I have this data and if I want to create a linear regression, I will go with the scatter chart. It's very simple. Now, as observing in the previous example, all the dots were creating a straight line, and that r square was equal to 1, which is 100% accuracy. But now we have a different kind of pattern. Whenever we increase the salesperson, the sales are also increasing, but with a different addition and also decreasing as well. Now we need a straight line closest to these dots so that we can predict what is going on. Okay, so it's very easy. What we will do is I will just click on this chart, click on this plus sign at the right side, adding a trend line, click on more options, and then I will enable two options. The first one is display equation on chart and then display r squared value on chart. And now let's understand these two equations or these two statistical concepts. Now r square means r square value gives 0.9717. This means that if I apply the above equation, which is y is equals to 9.7857x plus 9.3871, this equation, the next number which I will get, will have an accuracy of 97%. Okay, so the above equation, which is y is equals to mx plus c, I hope you in your statistical subject you have gone through these kind of concepts like regression and y is equals to mx plus c. So r squared tells you that if you apply the above equation, the next number give you 97% of accuracy. Might be 3% will be inaccurate. So let's do it. Let's predict the next number. So it says 9.7. I am putting the next sale person, which is 11, into the equation. So 9.7857 multiply by 11, and then adding a constant value, which is 9.3871 in the equation. So the next predicted number is, if we have 11 salesperson, so our next sales will be 117.03. And we can also perform the same by using the forecast function as well. We can apply the forecast linear, where we will give 11th as an x value, known y's will be the previous sales number, and known x will be the previous salesperson count. So this also returns 117.03. So the forecast dot linear, and by doing with an equation which is y is equals to mx plus c, is also gives the same answer. So this is how you understand the statistics and the regression portion within the Excel. So I hope this example is now clear to you. Now let's come to the next example. This is example number 3. Now here we have again two columns, salesperson and the sales, but now a very different kind of behavior of the sales. When there is no salesperson, there is no sales. Now, as soon as the salesperson are increasing, sometimes the sales are increasing and sometimes sales are decreasing with a difference, right? So if any one of you can predict what will be the next sales if I add one more salesperson to the organization. So I want your feedback in the chat window. So let's say if we can do with a forecast dot linear, so known x, the x value will be the next number which we are predicting it. Known y's are the sales numbers, known x are the previous salesperson count, and that is 85.78. Now let's cross check it. If 85.78 will come through y is equals to mx plus c or not. So let's cross check it. I will just select the data, going to the insert tab, click on scatter chart, and now I will add a trend line to it. So for adding a trend line, as you know that you will click on plus sign, clicking the arrow, more options. Now as you can see, there is a straight line which is closest to the dots as much as possible, and I'm enabling two options, which is the display equation on chart and display R square value on chart. Now this says R square says 0.4544, which means that if I apply the above equation basically, if I apply the above equation, which is y is equals to 6.7034x plus 12.05. So that answer will be 45% accurate. Now the accuracy percentage is very low here. And there are different techniques to increase the R square as well. And if you are a statistics person, if you are subject matter expert, you know that you play with the outliers in the data. You decrease the outliers as well. But in this example, let's predict the next number. So according to the equation, which says 6.7034 multiplying by the 11 and then adding a constant value to it, which is 12.05. So see, it gives me a next number, which is 85.78. Now this 85 is 45% accurate. And as I told you that if you need to increase the accuracy, you have different tools to it, different techniques to apply that. So this was the third example. Next example. Now in the next example, there are 4 independent variables and there is one dependent variable. So the dependent variable is the current price, and the independent variables are now the multiple independent variables. The first one is average house price, years old, number of rooms, and area in square yards. Now for example, I'm going in an area where I need to purchase a house for myself or for my family, and I have collected a data from there from the nearby houses. So I have collected a data of nearly 499 houses nearby where I need to purchase a new house for myself. And I want to predict the next value that according to these independent and dependent variables, what will be the price in which I can get the house. Okay. So this again, this data is not the real-time data. This data is the dummy data, fictitious data, fake data. Just to explain you that how you apply the regression in Excel when you have a multiple independent variables. Okay. So once you have multiple independent variables and you want to apply the linear regression, first you need to see that either you have the data analysis option enable or not. Okay, so let me check. So I need to enable the data analysis option. For enabling the data analysis feature, what you need to do is first you will click on file, then options, Okay, and from here, this Excel options window, you will click on add-ins, and in the manage, you will select the Excel add-ins and click on go. And here you can have the analysis tool pack enabled, right? And also the solver add-in, but I guess it's analysis tool pack. So when I click on it, Excel will be enabling the analysis tool pack in next few minutes. Okay. So from here, I can't see the data analysis feature. I guess I need to restart the Excel. So let me restart the Excel for one more time and let me show you that how to get the data analysis option. So waiting for a few more minutes so that Excel could restart and we can explore the data analysis option. All right, now we have the data analysis here, right? So once again, let me repeat it. If you don't find the data analysis option in the data tab, what you need to do is going to file, then click on options, and here you will go in the add-ins, and in the manage you will click on Excel add-ins, click on go, and make sure that you have a check mark on analysis tool pack. Okay, so you will get the data analysis feature enabled on your data ribbon. Now I will open a file, and we will try to solve this linear regression example where we have more than one independent variable by the help of data analysis. Once you click on data analysis, a window will appear, and from this list you will select regression. Okay, and press the OK button. Now there are few fields which you need to input them, and those are that you need to fill the range, which is the y, which is the dependent variable. You need to fill the range x, which are the independent variables. Okay, so first let me select the range of y, which is the current price given in column E. Input x range will be the independent variables. In this example, we have column A to D. We have 4 independent variables. The next option is of labels. As I know that my data first row consists of titles or the labels, so I need to check mark that. So I make sure that I am telling the Excel regression that the first row is of labels. The constant is 0. Now this is very technical because sometimes you want the constant to be 0 and sometimes you need a constant. So based on your statistical concepts, you need to check or uncheck this option. So in this example where I need to find a house for myself based on the data which I have collected for the various houses, there is no constant field here. So I will check mark constant as 0. The next option is confidence interval. If you have done with the statistics and you have gone through confidence interval, sometimes we take 90% confidence interval, sometimes we take 95%, even sometimes we take the 99%. So the confidence interval, if you want to add it, just check mark it. And let me tell you what the confidence interval is. The confidence interval is the range surrounding each predicted value, which is in this case is 95%, of future points are expected to fall based on the forecast. And remember that this is with the normal distribution. Confidence interval can help you to figure out the accuracy of the prediction. So a smaller interval implies more confidence in the prediction for the specific point, and as you can see, the default is the 95%. Okay, I will get the result. I want the result in a new worksheet, and also you can apply the other residuals if you know if you want to add it or not. When I press OK, a new sheet will open as a summary output, and each of the number is telling you something. even more than that. If you are very strong in the statistics, you know what is ANOVA, what is mean by the adjusted square, R square, how to create an equation which is y is equals to mx plus c, which I told you earlier in the webinar. So we have 4 independent variables right here, R square value here. This means that if I create an equation of these 4 variables and I will put a value to it, I will get a result with 76% of the accuracy. Okay. And the equation will be like, if I put all these 4 variables, so I need to have a current price. So the current price is equals to 0.11 0.12291 multiplied by average house price plus 419015 multiplied by years old. Now, how I am making this equation, because as I told you that we have 4 independent variables here and all these values are here given. So what will be the equation? Normally y is equals to mx plus c, and we have more than one independent variable, so it will go like m1 x1 plus m2 x2 and so on. Okay, and when we will put our next value to it, it will give you 76% of the accuracy, because R square is 76%. So that's how you apply the linear regression. And even more than that, you have the confidence interval which you selected 95%, so you have lower bounds and the upper bounds. So if you purely a statistics person, you know that what this data is telling you, right? And going